This handout from that Master Math Mentor site is kind of like a combination of Lippmann 7.3 and 7.4. So I figured I'd do examples from that, and that way we'll be able to get double use out of it. And this is this set of definitions is in the Lippmann book, and it's also on that handout. And what we're going to do is we're going to be using these to write some ratios, find missing sides, that kind of thing. First example in that Master Math Mentor handout is what we need to do is we need to draw the triangle that each of these points represents, find the missing side, and it's always the hypotenuse in this case, and then write ratios for the 6 trig functions. So for this first one, I graphed the point 3, 4. The x was 3, the y was 4, so the coordinates to that point are 3, 4, and that means the y, or the opposite side from the angle, is 4 along. The adjacent side is 3 along, and if you use the Pythagorean Theorem, or if you ever learned about the Pythagorean Triples, you'd know that the hypotenuse is 5, because 3 squared plus 4 squared has to equal 5 squared. And so now I've got I got the opposite side, the adjacent side, and the hypotenuse. So to write the sine of that angle, we know that sine is opposite over hypotenuse, so 4 over 5. The cosine is the adjacent over the hypotenuse. That's where I got the 3 over 5. Tangent's opposite side divided by the adjacent side. So that's the 4 over 3. And then we get into the reciprocal functions. And the cotangent's the reciprocal of the tangent. So if you know the tangent, you just take the reciprocal of it, and that's the cotangent. The secant's the reciprocal of the cosine. So 3 over 5 becomes 5 over 3. And for the secant's the reciprocal, the cosecant's the reciprocal of the sine. So if the sine's 4 over 5, the cosecant's 5 over 4. Now, one way to remember these reciprocal functions, with tangent, cotangent's usually pretty easy. But to do the rest of them, we know the secant and the cosine are reciprocals, and S goes with C is the way I remember this. All right, and same thing, S goes with C. So the sine and the cosecant are reciprocals. Okay, so that's one way to remember this. Now for this next point, same kind of idea. The x is 8, the y is 15. I said that backwards. The x is 15, the y is 8. To find that hypotenuse side, well, let's see. I'm not seeing a slick triple, so 8 squared plus 15 squared has to equal c squared, and I can't write 15 here. 15 squared, then I'm going to take the square root, so 64 plus, what is 15 squared? 225. And that's 9, 8, 289, 8, 15, 17. That is a triple. Okay. So then, since we know the sides, and there's the angle that we're talking about, we can say that, let's see, can I get this out of the way enough? The sine's the 8 over 17, cosine's 15 over 17, tangent's 8 over 15. Then if you stop and think about it for a minute, we're just going to take the reciprocals of each of these. So what is this? 8 over 15, and then 17 over 15, and then 17 over 8. Okay? So the rest of these are kind of the same. I mean, this is the same kind of idea. You'll have to find the hypotenuse, same there. This one's a little bit different, so probably we ought to do these last two. So for this last one, or this next to last one, we know that coordinate is 1, 1. And hopefully this triggers in your mind one of those special right triangles. Since this is an isosceles right triangle, both those angles are 45, which means if we use the Pythagorean theorem, this side is the square root of 2. And so now to find all the trig values of this, well, sine is 1 over the square root of 2, and that's a perfectly acceptable answer Some textbooks will make you rationalize it. I think Lippmann does. So to rationalize it, what you got to remember is we've got to get rid of the radical in the denominator. So I'm going to multiply by 1, which becomes root 2 over 2. Okay. And then cosine's the exact same value because the adjacent's the same as the opposite, so root 2 over 2. Now, the tangent is opposite over adjacent, which in this case is 1 over 1. Cotangent's going to be the reciprocal of that. Now comes the part, I know that, let's see, the cosecant is the reciprocal of the sine. Well, if the sine is 1 over root 2, the reciprocal of that will be just the square root of 2 over 1, which we don't have to worry about it. And secant's that same thing. Okay? So over this last one, square root of 2, square root of 7. So x is the square root of 2, y is the square root of 7. And if you do square root of 2 squared plus the square root of 7 squared, add them together, take the square root. Why did I write 2 again? This should be 7. Can I erase all that? Oh, I can. So the square root of 7 squared. So that becomes 2 plus 7, which is 9, and the square root of 9 is 3. So sine is square root 7 over 3. Cosine square root 2 over 3. Tangent is the square root of 7 over 2, so we could write that as one big square root if we wanted to. All right, 7 over 2. And the cotangent's reciprocal of that, so one big square root 2 over 7. Secant's going to be the reciprocal of the cosine, so 3 over the square root of 2, and if we rationalize that by multiplying by root 2 over root 2, that's going to give me 3 square roots of 2 over 2, 2 over 2. And then the cosecant will be 3 over the square root of 7, which rationalize that becomes 3 square roots of 7 over 7. Okay, so that's everything's been in the first quadrant. We move on from here. So now we're on to the second example that's in that handout, and they give us some points that are not in the first quadrant. So we still the same kind of idea. We have to graph the points, come up with a triangle, find the hypotenuse. And what I'm hoping you have learned in the past, and if not, it's pretty easy to pick up now. These Pythagorean triples can be multiples of each other because they're just similar triangles. So 3, 4, 5 is the primitive, or the base they call it for this. And I noticed that I was going to use this because I know 3 times 2 is 6, 4 times 2 is 8, so 5 times 2 has to be 10. That tells me this side is 10. If you use a Pythagorean theorem, you'll also get 10. If you use the Pythagorean theorem, that we don't have to worry about the negative also, because that squares out and becomes positive, right? So now to find the sine and the cosine, we're just gonna use the same thing, opposite over hypotenuse, and we should reduce that, simplify that to 3 over 5. The cosine becomes negative 8 over 10, which becomes negative 4 over 5, and I'll talk about that in a minute here. The tangent becomes 6 over negative 8, which is negative 3 over 4. The cotangent's reciprocal of that, so negative 4 over 3. The secant's reciprocal of the cosine, which is negative 5 over 4. The cosecant's reciprocal of the sine, which becomes 5 over 3. Now on that My Open Math, or Master Math Mentor handout, now let's see, can I move this out of the way? Maybe not. He has this kind of thing drawn, a sketch drawn, and then he talks about using ASTC. One way to remember this is that all seniors turn crazy. I use that with my high school seniors. You can also think all students take calculus as a mnemonic to remember this. All students take calculus. Now what this tells us is what trig ratios are positive and in which quadrant. And the reason this works is because in the first quadrant, both x and y's are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive, y is negative. And what I'm hoping you start seeing is that, one of those shortcut things, cosine is another name for x over the radius. So the x-coordinate over the radius. The sine is the y-coordinate over the radius. The tangent is the y-coordinate over the x-coordinate. Cotangent is x-coordinate over y. Secant is radius over, and this is on the unit circle, is where we're going with this. The radius over the x, and the cosecant is the radius over the y. What I mean by the unit circle is we're going to be drawing, having points on a circle. In this case, it'll be a radius 10. Where we go to the unit circle, it'll be radius 1. Okay, and we'll extend this a little further there. So for this problem, we've got a point in the fourth quadrant. X is 7, y is negative 24. So 7, negative 24. And this is a 7, 24, 25 triple. Okay, so then same deal. Sine is going to be negative 24 over 25. So I write negative 25. Let's see, can I fix this? Cross it out. Negative 24 over 25. And notice down in this fourth quadrant, only the cosine is positive, and cosine is secant, of course. So the sine will be negative because that y is negative. So then we're going to do the cosine, which is 7 over 25. Cotangent will be negative 24 over 7 because it's the opposite side over that adjacent side, right? Then we're going to take the reciprocals, which becomes negative 7 over 24. Take the reciprocal of the cosine, which is 25 over 7. And 25 over negative 24. Now, one thing that comes up with people that have issues with, if you have a fraction that's negative 25 over 24, well, that's the same value as if you put the negative in the denominator with the 24. It also is the same value if you stick the negative out in front. Okay, so it doesn't really matter where you put that negative in a fraction, right? All right, let's do a couple more. So the next point is down in quadrant 3, and I used the Pythagorean Theorem to find the length of the hypotenuse. And we're going to do the same deal, and encourage you to not watch this part of the video. Stop it, try to fill in this table, and then come back and check and see if we agree. Okay, so to fill in this table, I know the sine is the opposite over the hypotenuse, so negative 2 over 2 square roots of 2, I'm seeing that the 2's will cancel out. So I'm left with negative 1 over the square root of 2, which rationalizes to negative root 2 over 2. And the cosine will be the exact same number, negative root 2 over 2, because it's isosceles. Tangent happens to be positive 1, because negative 2 divided by negative 2 is 1. And notice that corresponds with that the tangent's positive down here in quadrant 3. And because cotangents are reciprocal, that's also positive. Then we're going to come back to thinking about this. Remember, the secant and the cosine, the sine and the cosine are negative root 2 over 2, negative 1 over root 2 before we rationalized it. So if we're just going to take the reciprocal of this, we're just going to write negative square roots of 2, and the same thing for the cosecant. So for this last one, I plotted the point. I'm finding the length of the hypotenuse, and which is 2. Now, what I'm hoping that you remember from some time in the past, or it's also on that Master Math Mentor handout that this is a 30-60 right triangle, and we'll look at that again here in a little bit. But so that was the triple. That's one way to remember it without having to do the Pythagorean theorem. So same deal. We're going to write those ratios. And if we think about this, that's the square root of 3 over 2. That is negative 1/2. That is negative square root of 3 over 1. It's to negative square root of 3. Cotangent's the reciprocal of that. And I'm hoping you're seeing that we're going to have to rationalize it. So we're going to get the square root of 3 over let me walk through and do it. Will it let me walk through and do it? Okay, so the reciprocal of 1 over negative square root of 3. So that means I've got to rationalize it, which would give me negative square root of 3 over 3, because root 3 times root 3 is 3. And the secant is the reciprocal of the cosine, which is negative 2. And the cosecant is the reciprocal of the sine. So I'm going to take the reciprocal, and again I got to rationalize it. So that becomes 2 square roots of 3 over 3. And it's positive because in the second quadrant, the sine and because the cosecant is just the reciprocal of the sine are both positive. And notice all the other ones are negative. So for these kind of problems, this kind of extension, I know the sine equals 12 over 3. And it's in the first quadrant. So I know the opposite side is 12. I know the hypotenuse is 3. And this looks like it's a 5, 12, 13 triangle. Everything's positive. So they want me to find the sine and the cosine and the tangent. Well, cosine is going to be 5 over 13. Tangent is going to be 12 over 5. I'll write that down. So 5 over 13 and 12 over 5. So for this one, I know the cosine's 2 over 3, so the adjacent side is 2, the hypotenuse is 3. This opposite side of that's going to really be theta, isn't it? So this is really theta. That's just the reference triangle. So to go to use a Pythagorean theorem for this, so 3 squared minus 2 squared, because it's a squared plus b squared equals c squared, and since we don't know b, we're going to square the hypotenuse minus the square of that other side. Take the square root, so let's see, what is that? 9 minus 4, I'm getting 5, so the square root of 5 is this opposite, and it's negative because it's in the fourth quadrant. So let's see, so sine is going to be opposite over hypotenuse, sorry, the square root of 5, negative square root of 5, and tangent's going to be negative square root of 5 over 2, and that checks with the all students take calculus that only the secant and cosine will be positive, so that checks that these two are negative. So I know this is in quadrant 3. I know the tangent is the opposite over the adjacent. They're positive because it is in quadrant 3, except here it's negative and negative, because that I know the tangent is positive, and I know both x and y are negative down in quadrant 3. So that's how I was able to come up with those signs. To get the hypotenuse, we're just going to use the Pythagorean theorem. 3 squared plus 1 squared, and take the square root, so I'm getting the square root of 10. That's positive, of course, because you can't have a negative distance like that. So the square root of 10. So they want cosine. So cosine's adjacent over hypotenuse, so negative 1's the adjacent side over the hypotenuse, and we probably have to rationalize that. Multiply by root 10 over root 10. So that's the cosine. The cosecant is a reciprocal of the sine, so instead of opposite over hypotenuse, we're going to write hypotenuse over the opposite, or radius over y. So that's going to be the square root of 10 over 3, and it's negative. So for this one, they aren't telling us anything about what quadrant it falls in. So there's two places where this could occur, where the sine and cosecant are positive. It could happen here in quadrant 2. It can also happen in quadrant 1. And since it's hypotenuse over opposite and hypotenuse over opposite, we can use Pythagorean Theorem to find it. Over here it'll be negative, over here it'll be positive. So what do we have? 36 minus 25. Take the square root, so the square root of 11, and it's negative. Over here it's just positive square root of 11. So the two possible answers, if it's the cosine and it's in quadrant 2, well, that's going to be negative square roots of 11 over 6. If it's in quadrant 3, it's positive square roots. Quadrant 1, positive square root of 11 over 6. If they're looking for the cotangent, it will be, in this quadrant, it'll be 5 over negative root 11, which becomes negative 5 root 11 over 11 if you rationalize it. And of course, this is the same value. It's just going to be positive 5 square roots of 11 over 11. So I'm going to do a little bit of 30, 60, 45 right triangle review with you. At some point in time, hopefully you learn this, that if I have a 60-degree angle, and a 30-degree angle and a right triangle, the sides work out to be the side opposite the 30 degree is half the hypotenuse. So if the hypotenuse is 2, that means it's 1, and that the other side is half the hypotenuse times the square root of 3. And you might have seen it written this way. Whereas this is the 30-degree angle, and this is the hypotenuse, this is half the hypotenuse, and the side opposite, the 60-degree angle, is half the hypotenuse times the square root of 3. So if the hypotenuse is too long, the side opposite the 30s is 1, and the other one is 1 times the square root of 3. I didn't write the 1, of course. Now, and you know, the same thing holds if you just reverse the 60-degree angle, it's still half the hypotenuse. Well, if the hypotenuse happens to be 1, half of that is a half, and that's opposite the 30-degree angle. And the side opposite the 60-degree angle is half the hypotenuse times the square root of 3. Okay, so we often will write that square root of 3 over 2. So where we go with this is we're going to have angles of rotation on a circle, with a circle centered at the origin, and the initial ray is always the positive x-axis. And then what happens if, let's say, I want to turn an angular rotation of 120 degrees. That work starts in the positive x-axis, and I'm coming out, there's 90 degrees, and 120 degrees is somewhere between 90 and 180. And then I have my reference triangle. Always come back to the positive x-axis. And then what we want to do is find the reference angle. Well, if this is 120 degrees, I'm still missing 60 degrees to come all the way to 180. So that tells me that reference angle is 60 degrees. And if this is on the unit circle, meaning the radius is 1, that tells me that the opposite side is this square root of 3 over 2. Can't really write that well. And this is 1/2. And of course, this is the negative x-axis. So that's, now we're back to what we were just working on with finding points, except now we're talking about angles and angles of rotation. It's the same idea, just you're approaching it from angles versus coordinates. I could find the coordinates of this point because that's the x is negative 1/2. The y is positive square root 3 over 2. Now we're back to where we just got done doing all those examples of, okay? So, and this will always hold. And then you learned that the cosine is the same thing as, so if I'm looking for the cosine of 120 degrees, that's the same thing as the cosine of 60 degrees, because a reference angle is 60, except the cosine's negative in the second quadrant. And if the cosine is the adjacent side over the hypotenuse, that's the same thing as negative 1/2 over 1, which is the same. Why do we need the 1, which is negative 1/2? And then what I'm hoping you've made the connection sometime, if not now, that the cosine is the same thing as the x-coordinate when I'm talking about the unit circle. And the sine is the same thing as the y-coordinate. And then the tangent is the same thing as the y divided by the x, or the opposite side divided by the adjacent side. So it's y over x. So if I'm asking to find the tangent of 120 degrees, that's the same thing as the square root of 3 over 2 over negative 1/2, which means you got to take the reciprocal of the denominator and multiply. 2's cancel out, negative root 3. And that's how we're able to fill out that table that I shared with you on my old trig notes. I think I'll walk through some examples like that with those trig notes, except it's just a static, not the video. Okay? So what I want you to get out of this little explanation is that the cosine is the same thing as the x-coordinate, the sine's the same thing as the y-coordinate, tangents y over x, and then we can go with those reciprocal functions. So how do we deal with these quadrantal angles? Well, think about the unit circle. I'll try to draw a circle here. And if I have a 0 degrees or 0 radians, that point is on the unit circle, so the point is 1, 0. And since we know this is on the unit circle, the x-coordinate's 1, the y-coordinate is 0, and the radius is also 1 because it's the unit circle. And we know that from what we just said, if that point is 1, 0, the cosine is the x-coordinate, the sine is the y-coordinate. So if I wanted to find the sine of 0, that's 0. If I want to find the cosine of 0 radians, or 0 degrees, that's the same as the x-coordinate, which is 1. And the tangent will be the opposite over the adjacent, or the y over the x. Since there isn't a triangle to draw, we got to think of it this way, and that's going to be 0. Now if we take the reciprocals of these, 1 over 0 is undefined. So the cosecant's not defined at 0. The secant's 1 over 1. Tangent is undefined. Okay? Now if we go to the pi over 2, or 0, or 90 degrees, that coordinate is 0, 1. Cosine, so let's fill this in. X is 0, y is 1, radius is 1 again, unit circle. This point is 0, 1. Sine is the same thing as the y-coordinate. So sine is 1, cosine is 0. Tangent is undefined because 1 over 0, I can't divide by 0. Cosecant, 1, reciprocal of the sine. Secant's reciprocal of 0, so that's undefined. Cotangent's reciprocal of the tangent. Well, 1 over 0 is the reason why it was undefined, so 0 over 1 is 0. So I'll let you stop and think about it. Stop the video, think about what happens at pi radians, or 0, or 180 degrees. That's the coordinates because the radius is still 1. Fill this in and see if you can agree with my answers. So I'm assuming you did stop, and now you're looking back at this, checking your work. So the sine is the same thing as the x. I'm getting negative 1. Cosecant, I'm sorry, I just messed that up. Sine is the same thing as the y. Will it let me erase it? Oh, yes. Sine is the same thing as the y, which is 0. The reciprocal of that is undefined, because I can't divide by 0. Cosine is x, which is -1. Reciprocal of that is also -1. Tangent is y over x, opposite over adjacent. So that's 0. And the cotangent will be the reciprocal of that, which is undefined. So for 270 degrees, or an angular rotation of 3 pi over 2, we know the point is 0, -1, because the radius is still 1. So we know x is 0, y is -1, radius is 1. The sine is the same thing as the y, which is -1. The cosecant's reciprocal. The cosine is the same as the x. Reciprocal will be undefined. Tangent will be -1 over 0, which is undefined. And cotangent is 0 over -1, which is 0. So that's how you deal with the quadrantal angles.